Word problems. Okay, let's go. The sum of two numbers is 5. The larger number exceeds twice the smaller number by 15. We're going to set up let statements. Let's let x be equal to the larger number. And then we're going to let y be equal to the smaller number. And then we're going to do a direct translation. This is good skills that you need to practice for well, everything that follows. The sum means plus, so the sum of two numbers is 5. X plus y is equal to 5. That is equation number 1. We need a second one. The larger number, which is x, exceeds twice the smaller number. Well, that's 2y by 14. Exceeds also kind of implies plus, and exceeds means the larger number is 14 more than. It's another way of thinking about the word exceeds. 14 more than means 2y plus 14. So x is 2y plus 14. We're going to put a little single left side brace there to denote that these are the two equations we're going with, and then we're going to solve. So this is set up for substitution, taking this and plugging it in here. So I would go 2y plus 14 plus y is equal to 5. Keep going. 3y is equal to, if we subtract, we'd get negative 9. Divide by 3, I get y is equal to negative 3. If y is equal to negative 3, I'm going to rewrite that equation as x plus a negative 3 is equal to 5, or x is equal to 8. We're going to rewrite this now. The larger number is 8. The smaller number is negative 3. Circle that, and let's move on. The bank teller has 112 $5 bills and $10 bills for a total of $7.20. How many of each does the teller have? This is also easily set up with two variables. We're going to let x equal the number of $5 bills. Let y equal the number of $10 bills. And if it says you have 120 bills, not $5 bills, but 112 total bills, we know that x plus y is equal to the total number of 112. That is our total amount. That we'll call that our numbers. Then we have our dollar value. 5 times the number of $5 bills plus 10 times the number of $10 bills is equal to the total amount of money that you have. So this is probably a problem that's prime for either substitution or elimination. We're going to put this in single brace here. But if I kind of look at it even more closely, I can see that this second one, I can take out a least common denominator. I can divide both sides by a 5 to end up with x plus 2y is equal to 720 divided by 5 is 144. First one, I got x plus y. Let's make that negative x. Let's make that negative x minus y is equal to 112. Why did I do that? Well, I can now add these and do elimination. The x's drop out. 2y minus that y is y equals 256. No, that would not be right, because that's more bills than more money than we have. Forgot the negative 112. Hopefully you caught that, because you're not just mindlessly copying. That'd be sad. 32. Y equals 32. 32 number of $10 bills. That's better. If y is 32, then x plus y, so x plus 32 is equal to 112. Subtract, and I get x is equal to 80. Let's put a little sidebar and say, Mrs. Bank Teller has 80 $5 bills and 32 $10 bills. And continue. Tickets for the senior play cost $4 for adults and $2 for students. This year there are 600 tickets sold, and the class made this much money. How many of these types of tickets were sold? Let's let A be equal to the number of adult tickets, and let's let S equal the number of student tickets. Okay. We know that the A plus S equation is going to be 600, and we know that $4 times the number of A tickets plus $2 times the number of S tickets equals the amount they made, the $1,900. Let's do what we just did. We're going to take this equation, divide both sides by a 2, and get 2A plus S is equal to 950. Let's take this top equation, multiply through by a -1, get negative A minus S is equal to negative 600. And then we're going to come back and add these to get A equals, and that would be 250. Is it 250? 350. A equals 350. If A is 350, and 350 plus S from that equation is equal to 600, then I know that S is equal to 250. So, they sold 250 student tickets and 350 adult tickets. Flip it around to the back. Kathleen invested $5,000, some at 6% and the rest at 5%. Her annual income is $280. How much is invested? This goes back to our investment problems. So let's start with the let statements. Some at 6, some at 5. Let X equal the amount invested at 6%, and we're going to let Y equal the amount invested at 5%. And remember that 6% represents 0.06 and 5% represents 0.05. So we have our total amount invested, and that's where we kind of say, remember, X and Y are big numbers. And so if I add X and Y together, I get my total amount that I actually plugged in the investment, and that would be this $5,000. That's the total. Then we have the interest one, where we take the 6% times X plus the 5% times Y, and you get the amount of money you made off the investment. And that would just be a small $280. Because you don't make a lot off of investments right away, it just comes later. Okay, we're going to kind of do the same thing where we switch over to the right a little bit. I'm going to multiply the left and the right sides of this equation here by a number that's going to clear those decimals. If we want to move the decimal places right 2 places, I'm going to multiply by 100. If I multiply by 100, I get 6x plus 5y is equal to 28000. Then I'm going to take this top one and let's see. Well, let's just rewrite it. Let's do substitution on this one. I'm going to rewrite this one as y is equal to 5,000 minus x. So now I have my two equations again. I'm going to put the little braces there so we can see them. And I'm going to substitute. So 6x plus 5 times, I'm going to have 5,000 minus x equals 2800. Distribute 6x plus 25000 minus 5x is equal to 28000. On the left side, if I add, I get x, and then if I subtract 25,000, I get 3,000. X equals 3,000, and if x equals 3,000, y would equal 2,000, because 5,000 minus 3,000 is 2,000. Okay, so then we say she invested $3,000 at 6% and $2,000 at 5%. There's my complete sentence answer. Number 5, Sally has $21.40 in dimes and nickels for 100 coins. How many of each does she have? Let's let D equal the number of dimes, and let q equal the number of quarters. And if we add d plus q, I get the total number of coins, 100. And then if I say, well, what's the value of a dime? Let's figure out dollars and cents. Let's do dollars, or cents, because cents makes it so we don't have decimals. So 5 times d, nope, sorry, kidding. Dimes over 10, 10 times d, plus 25 times q equals, and we're going to express that in pennies, 2140. Then we're going to move that to the right and divide both sides by a 5. So if I pull a 5 out of both sides, I would get 2d plus 5q equals, and that would be 428. And then I'm going to take this top one, and let's solve that for maybe d or q, doesn't matter. D is equal to 100 minus q. And now I'm going to do substitution. 2 times 100 minus q. I should move this over here. Come on. This will let me know who's copying and who's not. Okay, fine. We'll just erase and rewrite it. 2 times 100 minus q plus 5q equals 428. Distribute. 200 minus 2q plus 5q is equal to 428. And then you'd have 3q is equal to 228. And if I divide, q is equal to 76. So if q is 76, plug that in here. D is 100 minus 76, which is 24. So there are 76 quarters and 24 dimes. Last problem. One number is 16 more than another. If a smaller number is subtracted from 2/3 of a larger number, let's let x equal smaller number, let y equal larger number, let one number is 16 more than another. Well, here's the one thing. If I took the smaller number, x, and I added 16, I would get the larger number. That's what it means to have one number 16 more than another. And then it says if the smaller number is subtracted from 2/3 of the larger number, so 2/3 of the larger number is 2/3 y, subtract the smaller number, the result, there's your equals, is 1/4 times the sum plus of the two numbers, x plus y. So our setup here is a little weird. Let's kind of pull these together. The first one's already set up for substitution, but before we do that, let's simplify this bottom one. I'm going to first distribute the 1/4. I'm going to work my way down. And then let's multiply the left and right side by an LCD of 12. If I do that, I'm going to clear all these fractions. If I multiply by 12. So 12 divided by 3 is 4, times 2 is 8y, minus 12x equals 3x plus 3y. And now I want to get everything at least over to one side. So let's move everything over to maybe the left. So the x's go over and I have minus 15x. The y's go over and I have 5y equals 0. And then I could divide both sides by a 5 to get y minus 3x equals 0. So this could be considered equation 1 up here, equation 2. Let's rewrite those on top of each other just to kind of get them together. X plus 16 is equal to y, and y minus 3x is equal to 0. Let's take this and substitute it in for x. So I have y minus 3 times x plus 16. Oops, just kidding, substituting in for y. Sorry, it is getting late. So then I have x plus 16 minus 3x is equal to 0, or negative 2x is equal to negative 16, or x is equal to 8. Take that, put it in the first equation up here, and I know that y is equal to 16 plus 8, or 24. So, the larger number is 24. The smaller number is 8.